Hello everyone, this session will discuss the Gaussian naive-Bayes classifier. Now when we should use Gaussian naive-Bayes classifier? So when my input features are continuous numerical values and my outputs are categorical values, we can use Gaussian naive-Bayes classifier. So your Gaussian naive-Bayes classifier work like a logistic regression. So you can compare the results of Gaussian naive-Bayes classifier with the logistic regression model. That also we will discuss in this session. So here in the Gaussian naive-Bayes classifier is useful when working with the continuous values and whose probabilities can be modeled using a Gaussian distribution, where we use the Gaussian probability density function. So in the scikit-learn library, some inbuilt data sets are given. For example, handwritten notes, then iris data set, right? So to implement the model for this data set, you can use the Gaussian naive-Bayes classifier. So like your other naive-Bayes classifier, also we calculate the probability of the query point here for the given class label. So here only the formula is different because my data input values are numerical values. So here is the formula for calculating the probability of the x, right? For example, P of x is equal to 1 upon square root of 2 into pi into rho square. Here rho square represents the variance of my attribute of the input features, then exponent of minus x minus mu, where mu represent the mean value of that particular attribute divided by 2 into again variance. So we'll discuss with example how Gaussian naive-Bayes classifier works. So for simplicity, consider this person's height data to predict the gender of that person. Right, so I assume this is a single dimensional data, and here my person is represented by the height only. And using this height, we want to predict the gender of that person. So there are total 8 records in the data set. So if you observe, for the height 3, 4, 5, 6, my class label is female. And for height 6, 7, 7, 6.6, my class label is male. So we can use this training data set to build the model, to train the model, and then we can use this model to predict the class of new test data set. So assume my in the given problem statement, this query point is also given. My query is 3.5. For that we want to calculate, we need to calculate the gender here. So how you will calculate this using Gaussian naive-Bayes classifier? We'll see the solution here. So we'll use here this formula, probability of this x, my query, for this class label male and female, right? So here x is nothing but my query, and c will represent my female and male. So for female and male, we will calculate this probability of the query point using this formula. Right, so here is the solution that I have calculated using Excel. Right, in the Excel I have taken here in this column H as the height of the person, Y is my class label. Right, so here there are total 4 records belongs to the class label female. So this is the mean value of this height of all the person. Then Q is my query point 3.5. Here we have calculated the variance by putting the ready-made formula in the Excel, right? Then again we are calculating here the exponent of this term. Here my exponent term is complete term xi minus mu into ci divided by 2 into variance, right? So this I have calculated here in the putting the formula into the Excel. So we are getting this value 0.2018. Then we are calculating square root of this value 2 into pi variance of ci. So that value we are getting here 2.80, right? And finally we have calculated here probability of the q for this class label f using this formula, that is equal to 0.072. Then after this, we calculated the probability of the query for this male class label. So there are again 4 records belonging to the male class, right? Here we have calculated the mean of all these values. Then variance we have calculated here, exponent term we have calculated here, and square root term we have calculated. So after putting this value, we get final probability of the Q for this male class label, that is equal to 0.000085. So if you compare this probability for the female and male class, you can observe for female, my probability is greater, right? So we check for the maximum probability. So here is the solution. Probability of the query point Q, that is 3.5. For the male is 0.00085, and probability of this 3.5 height for the female class label is 0.0721. So this probability of the query for the female is greater than probability of this Q for the male. So my Q is predicted as a female. So new person with the height 3.5 is predicted as a female here. Similarly, we can calculate for the query 6. If my query point is 6, you can calculate this probability using this formula. So after solving this equation, we get here probability of the 6 for the female class, that is equal to 0.3, and probability of the person with the height 6 is equal for the male class label, which is equal to 0.47. So if you compare this probability, the probability of this query for the male class is greater than probability of the query for the female class. So my person with the height 6 is predicted as a male here. I hope student you are clear with this solution, because it is a numerical data. We are using the Gaussian Navy-based classifier. So let us see the scikit-learn code for this Navy-based classifier. So and also not only scikit-learn code for the Navy-based classifier, we will calculate the accuracy of the Navy-based classifier, Gaussian Navy-based classifier, and also the logistic regression classifier, and we will compare this accuracy using ROC curve. So we'll discuss here the scikit-learn code for this, Python code for this. So here we are using the data set of 300 samples, which is created using the make classification method. So from sklearn.dataset import make classification, then we have initialized this variable with 300. That variable we are passing as a parameter to the make underscore classification function, right? So this is the first parameter. Second parameter is the number of feature. Third parameter is the number of class label. Then once your data set is ready, you can build the model, Navy-based Gaussian Navy-based classifier model. So for that, my inbuilt class is Gaussian capital NB. So you need to import this library from sklearn.navybase, import Gaussian Navy-base. Right, from sklearn.linear model, import logistic regression model. We will compare accuracy for this. Then from sklearn.metrics, import ROC curve and AUC, area under the curve function, right? With the help of this ROC and area under curve function, we will discuss the accuracy of both the model here, right? Then from sklearn.model selection, import trend split, right? So this function to split the data into the training and testing. So here with this statement Python code, we have divided the data set into the training and testing set. So again, we are using here 0.25 to take the 25% data set into the testing set and remaining 75% data into the training set. Then here we are creating the object of the Gaussian Navy-based classifier. So here my code is GNB is the name of my object is equal to Gaussian capital NB. Once you have created object of this Gaussian Navy-base, you can train the model using fit function. So gnb.fit xtrain comma ytrain will train the model. Here we will execute the fit function will execute the Gaussian Navy-based classifier for this training data set. Then we can predict the accuracy of this model using score function. So gnb.predict underscore probability. This predict underscore probability is the functions equivalent to the score function, which will calculate the accuracy of your model for this given test data set. So here in YGNB score function, we are storing this accuracy and we are calculating this accuracy using the predict underscore probability function, because my model or algorithm is based on the probability theory. This function is equivalent to the accuracy score function, right, where we are predicting the probability. Then here we are building the logistic regression model. Here we are creating the object of logistic regression, LR equal to logistic regression. Then we are training the model, right? Logistic regression model for this training data set. And again, we are calculating here the score of this logistic regression model using LR dot decision underscore function. So there are alternative methods to calculate the accuracy score. So that also you can learn here, right? So here we are passing X test as a parameter, right? Because for this X test data, we want to predict the class label, right? So here score will have the accuracy of the logistic regression model. Y underscore LR score will have the accuracy of the logistic regression model. Now here is the code to display the ROC curve, right? And the area under curve, right? So this ROC curve we are using to print the true positive rate. True positive rate is nothing but the sensitivity, right? Like your accuracy, sensitivity is a one of the accuracy metric, right? Accuracy measure that we are printing here with the help of this ROC curve. So you know the syntax for ROC curve, where my ROC underscore curve is the inbuilt method, and where we need to pass the actual Y and predicted Y, like your other accuracy metrics. So Y test is my actual Y and Y GNB score is the predicted Y. So not only we want to print here the sensitivity of this Gaussian naive-Bayes classifier, this statement is to calculate the ROC curve for the Gaussian naive-Bayes classifier, right? Where we are fetching what? False positive rate of the Gaussian naive-Bayes classifier and true positive rate of the Gaussian naive-Bayes classifier. This is the statement where we are calculating the false positive rate of the logistic regression and true positive rate of the logistic regression. So ROC underscore curve, right, will find these values where we are passing as a parameter Y test and YLR score. Actual Y and the predicted Y by the logistic regression model. I hope student you are clear with this. Now we want to print this value into the curve, right? So here is the ROC curve for both the model. So red line represent my Gaussian naive-Bayes classifier, right? And green line represent here the logistic regression classifier. So you can observe here for the Gaussian naive-Bayes classifier, my area under curve is 0.96. And for logistic regression model, it is 0.95 for the same data set, right? So my here of this curve, this y-axis represented two positive rate, that is the sensitivity, right? So this represent what? The correctly classified records, and false positive rate, x-axis represent false positive rate, that is misclassified records, right? So definitely my data, this curve we are finding in the above of this dotted line, right, on the true positive rate side, right? So my accuracy is accepted here, right, for both the model. And if we compare both the model, here my naive-Bayes classifier is giving better accuracy than the logistic regression classifier. I hope student you are clear with this. Thank you.